All right, today we're diving into a machine that was born to operate in the absolute most hostile places on our planet. We're talking about a robot built to go where people can't, and frankly, where most other machines just give up. This is the story of the Icedrone.
You know, you look at Earth's polar regions. They are breathtakingly beautiful, right? But for technology, they're basically graveyards. The insane cold, the slick ice, the brutal weather, it can kill even the most advanced tech in just a few minutes.
And that creates a massive problem. I mean, how are you supposed to study these incredibly important environments, or check on vital infrastructure, or even run search and rescue missions when all your tools freeze and break? Clearly, we needed a whole new way of thinking.
Think about it. Your standard ground robots, the ones with wheels, they just spin out, totally useless on the ice. And what about aerial drones? Oh man, their batteries die almost instantly in that kind of cold, and their propellers can literally ice over mid-flight. It's not just that it doesn't work, it's incredibly dangerous, and it puts human operators in a really tough spot. So to crack this tough nut, engineers went back to the drawing board. They created a whole new kind of robot, one designed from its very core to not just survive, but thrive in these conditions. And that, my friends, is the Icedrone.
So the official term is a mouthful: an advanced, autonomous, hybrid robotic platform. But the word you really want to focus on there is hybrid. This thing isn't just a car with skis slapped on, and it's not a drone that's afraid of heights. No, it's something totally new, custom built for a very specific and very tough job.
And these two images really show you its dual personality, don't they? On the left, you see the clean, complex engineering all put together in a perfect, controlled lab. And on the right, you see that exact same machine in its natural habitat, the raw, wild, unforgiving ice. It's a perfect bridge between precision design and rugged, real-world survival. This quote from the source material just nails it. The Icedrone works in that sweet spot where ground robots can't get traction and aerial drones are just too fragile. It fills a huge gap, giving us a brand new tool for exploration and, of course, for safety.
Okay, so that's the what. Let's get into the fun part, the how. How does this thing actually work? What are the secret ingredients that let it take on the cold and win?
First up, let's talk about how it moves. The simplest way to picture it is to think of it as part snowmobile and part drone. It's built to glide gracefully over the ice, not to fight it.
At its core, it's got this dual ice skid system, which gives it amazing stability on frozen ground. But hey, what happens when it hits a patch of snow or bare rock? Well, that's what the auxiliary all-terrain wheels are for. Throw in some heavy-duty, shock-absorbing suspension and super precise controls, and you end up with a machine that can handle just about any treacherous surface ice can throw at it.
But look, being able to move is only half the battle. Just surviving at minus 40 degrees Celsius, well, that requires a whole other level of genius engineering. For a robot, it's all about keeping the lights on and the power flowing.
The Icedrone's got this specially designed battery pack that's made for the extreme cold. But the real secret sauce is its thermal management system. I mean, think of it like a high-tech parka for all its electronics, complete with insulation and even its own internal heater. It's also incredibly smart about how it uses every drop of power, and for those really long missions, you can even hook up a hybrid energy module to give it extra legs.
So, beyond just moving and surviving, the Icedrone is designed to be a total chameleon. It's not a one-trick pony. It's a technological framework that can adapt to almost any mission.
Its open frame design and modular mounting rails are basically like a universal adapter for science and exploration. You can quickly swap out different tools. One day it might be carrying high-res cameras for an inspection, and the very next day it could be kitted out with thermal sensors for a rescue mission or specialized instruments for studying a glacier.
Now, a great design on paper is one thing, but proving it actually works in the real world is everything. The Icedrone isn't just a cool idea. It was engineered to be thrown into a brutal series of tests, a real gauntlet, to make sure every single piece was up to the job.
And I mean, this validation process is intense. They don't just see if it works, they measure everything. They run cold soak tests where they literally leave it in a giant freezer at minus 30 degrees just to see how the battery holds up. They test its agility, its strength, and, maybe most importantly, all of its safety fail-safes. This is serious, top-tier engineering.
So, after all of that incredible design and all of that grueling testing, we finally get to the really exciting part. What can we actually do with this thing? Why does it all matter?
Well, the applications are huge, and they're incredibly important.
For scientists, it means they can get data from dangerous glaciers without risking a single human life. For industry, it can check on critical infrastructure like pipelines in frozen wastelands, maybe preventing a disaster. And for all of us, it can be a key tool in tracking climate change by monitoring the environment, and even in life-or-death search and rescue missions where every single second counts.
When you boil it all down, what you have is a single, super adaptable platform that's built for science, for safety, and for surveillance. It lets us extend our senses into the world's most extreme places, gathering critical information and doing vital work without putting anyone in harm's way.
So what does a technology like this really signal? What does it mean for the future of how we explore our own planet?
The Icedrone isn't just one cool robot. It's a pioneer. It's laying down a new foundation, a blueprint for a whole new generation of autonomous systems that can operate anywhere, no matter how cold, how high, or how harsh. It's really the start of a whole new era.
And when you look at this picture of it, all alone out there on the ice, you really get a sense of that future, don't you? It's like a silent, tough, resilient explorer, just waiting, ready for whatever challenge comes next.
And that really leaves you with one final, massive, and truly exciting question. As machines like the Icedrone get better and better, what are we finally going to discover when no place on Earth is truly off limits anymore?